Welcome to Apache Kafka Big Picture for Beginners. I'm assuming that you are an absolute beginner. So, we are going to start from scratch. In this first lecture, I'm going to talk about the following things. Let's start with the first question. What is Apache Kafka? If you look at the Apache Kafka documentation, it says Apache Kafka is a distributed streaming platform. What does it mean? It means two things. You can use Apache Kafka to create one or more real-time streams of data. And you can use Apache Kafka to process these streams and produce results in real time. When I say real time, I mean minutes, seconds, and even milliseconds. Let's assume you have a smart electricity meter in your house, and your meter is generating load-related data every minute. This data somehow goes to your Kafka server. So, the Kafka server continuously receives data every minute from a smart meter. Similarly, the same Kafka server receives data from other meters in your city, and all that comes to the Kafka server, resulting in a continuous stream of data. This is what we call a real-time stream of data. And bringing data from your smart meter to your Kafka server is what we call creating real-time streams. Now, once your data is coming and landing into Apache Kafka server, you have also created an application to read and process this data. Your application might be doing a variety of things. For example, you are computing and monitoring the overall electricity load for every house. As soon as the charge goes above a predefined threshold, let's say 2 kVA, you are sending an SMS to the house owner to alert him. But this kind of SMS alert doesn't make any sense after an hour, and you want to send such alerts in seconds or at least in 2-3 minutes, right? So your application is not accumulating data and then processing it to compute if the threshold is broken. It must be continuously listening to the data and processing it as soon as the data arrives at the Kafka server. And that is what we call real-time stream processing. So the answer to the first question is this. Apache Kafka is a highly scalable and distributed platform for creating and processing streams in real time. Now the next question, how does it work? Kafka adopted pub-sub messaging system architecture, and it works as an enterprise messaging system. I hope you already understand enterprise messaging system architecture. If not, nothing to worry about. I'm going to explain it right here. A typical messaging system has got three components: producer, message broker, and consumer. A producer is a client application that sends data records. These data records are called messages. The broker is responsible for receiving messages from the producers and storing them into local storage. Finally, the consumers are again client applications that read messages from the broker and process them. In this architecture, the broker is in the center and acts as a middleman between producers and consumers. If you recall the same smart meter example, the left side of the system, including your smart meter, acts as a data producer. The Kafka server in the center is the message broker. Finally, the right side box where you have an application is the consumer. This is a 50,000 feet view of how Kafka works, but it answers your question. Kafka works as a pub-sub messaging system, where we create producer applications to send data as a stream. We install and configure Kafka server to act as a message broker. And finally, we create consumer applications to process the data stream in real time. That is all. The next question is this. Where does it come from? Kafka was initially conceptualized and developed by LinkedIn and later open sourced in 2011. However, in the beginning, Kafka was designed to handle the data integration problem. Let's try to understand the LinkedIn problem. Here is a diagram that I borrowed from Jay Krebs' blog. Jay Krebs was leading Kafka at LinkedIn, and now he is the CEO of Confluent Inc. So, this diagram explains the data integration problem in a large enterprise. In this diagram, all these boxes are different application backends. They all generate and store some data. However, the data generated at one application is often needed by other applications as well. So, you have a requirement to share or send data from one application to another application. All these lines are showing data movement from a source application to a destination application. In a growing organization, the number of source and destination system keeps growing. Finally, you will end up in a situation like this. Some parts of these pipelines will keep breaking every day, and situation becomes like a big mess to maintain. LinkedIn tried to solve this problem using pub-sub messaging architecture, and the result looked like this. They placed a broker in the middle, and other applications started working as a producer and consumer. This architecture offered them a bunch of advantages and simplified the solution. We will learn more about the benefits of this architecture. However, you got your answer to the question, where does it come from? The next question is this: how it evolved from a data integration solution to a streaming platform. Kafka initially started with two things: server software that you can install and configure to work as a message broker, a Java client API library to help with the following: create Kafka producer applications and create consumer applications. But later, Kafka aspired to become a full-fledged real-time streaming platform. And to achieve that objective, they augmented Kafka with three more components: Kafka Connect, Kafka Streams, and KSQL. Kafka Connect and Kafka Streams are still open source components, and they are available with Apache 2.0 license. However, KSQL is available with some licensing restrictions and offered by Confluent as a commercial tool. So, to answer your question, from 2011 to 2019, Kafka evolved as a set of 5 components: Kafka Broker, which is the central server system; Kafka Client APIs, which is a producer and consumer API library; Kafka Connect, which addresses the initial data integration problem for which Kafka was initially designed; Kafka Streams. This one is another library for creating real-time stream processing applications; KSQL. With KSQL, Kafka is now aiming to become a real-time database and capture some market share in databases and DWBI space. Finally, the last question of this lecture: where does it fit into an enterprise application ecosystem? By adopting pub-sub semantics, Apache Kafka is becoming the circulatory system of your data ecosystem. In this case, just like your circulatory system carries blood, Kafka brings data to various members of the infrastructure. Kafka occupies a central place in your real-time data integration infrastructure. The data producers can send data like messages, and they can send it to Kafka Broker as quickly as the business event occurs. Data consumers can consume the messages from the broker as soon as data arrives at the broker. With careful design, the messages can reach from producers to consumers in milliseconds. The producers and consumers are completely decoupled, and they do not need tight coupling or direct connections. They always interact with the Kafka broker using a consistent interface. Producers do not need to be concerned about who is using the data, and they just send the data once, without worrying about how many consumers would be reading it. Producers and consumers can be added, removed, and modified as the business case evolves. Great! That's all for the overview. See you in the next lecture. Keep learning and keep growing.